Hi students, welcome to Chemistry Online. In previous class we discussed about closed packed structures. How the packing is going on in crystal solids means one dimension, two dimension, three dimension. Now we are going to discuss imperfections in solids. Imperfections in solids is nothing but imperfections are defects. We are going to discuss imperfections in solids. Okay, first of all, you know what are imperfections means some defects. See, when one state of the substance can be converted into crystalline form, the process of crystallization means the process of converting one state of the substance into crystal is nothing but a crystallization. In the process of crystallization, some defects are formed in crystals. They are nothing but imperfections in or defects in the solids. Imperfections or defects in solids. In solids. Okay. Imperfections or defects in solids. We are going to discuss. Defects is nothing but imperfections. So, how the defects or imperfections formed in crystals means the process of crystallization. What is the crystallization? Crystallization means converting one state of the substance into solid state. The process of converting one form of the substance, one state of the substance into crystal is nothing but a crystallization. In the crystallization process, arrangement of the atoms or arrangement of the points, arrangement of the molecules in some defects are formed. They are nothing but imperfections in solids. So, these are two types. How many types of imperfections we have? Two types. Okay. How many types of imperfections we have means two types. The first one is point defects. First one is point defects. It is the first one is nothing but a point defects. Okay. The second one is nothing but lattice defects. Lattice defects. Okay. So, the imperfections are two types. First one point defects and second one is lattice defects. See, what are point defects means the defects are formed around a point in the crystal lattice is called point defects. Point defects may be classified into four types. How many types? Four types. Point defects may be classified into four types. The first one is nothing but vacancy, means stoichiometric defects. Three types only. Stoichiometric. Stoichiometric defects. And second one is non-stoichiometric defects. Non-stoichiometric defects. And third one is impurity defects. Impurity defects. Impurity defects. How many types? This is a stoichiometric and it is a non-stoichiometric. non-stoichiometric, it is nothing but impurity defects. Okay, so stoichiometric defects means the defects are arised in stoichiometric compounds only. Okay, there are four types. Stoichiometric defects again divided into four types. The first one is nothing but vacancy defects. Vacancy defects. And second one is nothing but interstitial defects. Interstitial defects. And third one is nothing but SCHOTKY defect. SCHOTKY defect. And fourth one is FRENKEL defect. FRENKEL defect. These two are important. These two are important. Non-stoichiometric defects. Non-stoichiometric defects again divided into two types. The first one is nothing but metal deficiency defect. Metal deficiency defect. And one more type is nothing but metal excess defects. Metal excess defects. It is metal deficiency defect, it is metal excess defect. Impurity defects is only one type. So here lattice defects is again divided into two types. Lattice defects means that the defects are in a lattice, is nothing but lattice defects. The first one is nothing but line defects. First one is nothing but line defects, and second one is nothing but plane defects. Second one is nothing but plane defects. So these two defects we are not going to discuss in this class. Line defects is nothing but if you take a plane, atoms are arranged in a line. In the line, defects are formed, means that is nothing but a line defects. Plane means so crystal having many planes, first plane, second plane, third plane. The defects are around a plane, is nothing but a plane defects. Okay, so these are line defects and these are plane defects. And here it is nothing but impurity defects. It is nothing but stoichiometric defects. It is nothing but non-stoichiometric defects. So a metal excess defects again divided into two types. This is again divided into two types. Okay, so first one is nothing but so metal excess defects is it is a metal excess defect due to presence of cations, excess of cations, and this is the first one excess of cations, and this one excess of anions. Okay, a metal excess defects is two types. Excess of cations is one type, excess of anions is one type. This is imperfections in solids. Imperfections in solids is two types. This is point defects and is nothing but one more type is nothing but lattice defects. So point defects again classified into three types: stoichiometric, non-stoichiometric, impurity defects. Stoichiometric again divided into classifiers into 4 types. So vacancy, intrinsic, Schottky, FRENKEL. Next, non-stoichiometric, metal deficiency defects and then metal excess defects. Metal excess defects again classified into due to presence of extra metal. So metal excess defects are formed. Due to presence of metal deficiency means non-stoichiometric compounds. So the composition of the metal is less in the crystal, then metal deficiency defects are formed. Okay, for example, industrial compounds, metal excess defects. So cationic excess and anionic excess. It is example. So we will discuss next. First we have to discuss about Schottky and FRENKEL. Okay. Next, Schottky defect. Schottky defect. So if you take a crystal which contains anions and cations, here I am going to explain Schottky defect and FRENKEL defect. Here FRENKEL defect. FRENKEL defect. Okay. Schottky defect means see, it contains C, cation, anion, 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 C, A, C, A. C equal to cat ion, A equal to ion ion. In this crystal, electrical neutrality is formed due to missing of one cation and one anion also missing from its normal site. So this defect is formed due to missing of equal number of cations and anions in the crystal. So this defect is formed. Here if you take anion is missing from its site and it is anion, and here cation also missing from its site. So it is a missing of cation and anion. Due to missing of equal number of cations and anions, this defect is formed. Due to missing of equal number of cations and anions in the crystal. In the crystal, due to missing of equal number of cations and anions in the crystal, is called Schottky defect. For example, FRENKEL defect. FRENKEL defect. It is also cation like this. It is a anion cation, 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 anion cation. Okay, this is a cation, anion, cation, anion, cation. So one cation, small cation. So here cation is a small, cation equal to small anion equal to large. Large. See here, small size cation will be missing from its normal position to dislocated interstitial site. For example, if you take cation, it is its normal position. It is dislocated to here. Cation is shifted. Small cation is shifted from its normal site to interstitial site. It is its normal site. It occupies a interstitial site. Due to dislocation of cation, this defect is formed. It is also called FRENKEL dislocation defect or a FRENKEL defect. So, due to dislocation of small cation in the crystal, due to dislocation of small cation in the crystal, so FRENKEL defect is formed. It is due to missing of equal number of cations and anions in the crystal, SCHOTKY defect is formed. Then here density decreases. In this crystal, so density decreases. In these crystals, no change in density. No change in density. Okay. Here we may give example NaCl. Okay. Next AgBr, CsCl. All these are examples for SCHOTKY defect. Here we may give AgBr and AgCl and AgI. All these are example for FRENKEL defect. So this is nothing but a SCHOTKY defect and a FRENKEL defect. These two defects are very important for 4 marks. It is also important for 4 marks. Okay, this is a SCHOTKY defect and it is a FRENKEL defect. SCHOTKY defect is also called, what is this also called? So how SCHOTKY defect is formed means due to missing of equal number of cations and anions in the crystal, SCHOTKY defect is formed. Here how FRENKEL defect is formed means small cations are changing its position normal site to interstitial site. It is nothing but a special site or a interstitial site. Due to this dislocation of cations in the crystal, okay, FRENKEL defect is formed. FRENKEL defect is also called dislocation defect. So here density will be decreases. Here missing cations and anions, then automatically weight will be decreases. Weight means density will be decreases. Here no change in density. So atom shifted but not missing. Here example NaCl, AgBr, CsCl. Here AgBr, AgCl, AgI. Okay. So this is. Here you have to know a note. What is a note means? Very important note. AgBr shows both defects. SCHOTKY and FRENKEL. Okay, both defects. SCHOTKY and FRENKEL. AgBr shows both the defects, SCHOTKY and FRENKEL. Okay, this is about stoichiometric defects. Next, non-stoichiometric defects. Non-stoichiometric means composition of the metals, means in the crystal composition of the metal is not good. That is nothing but a non-stoichiometric defects. Here metal deficiency defects and metal excess defects. Metal deficiency defects is nothing but industrial compounds. Example, industrial compounds. See, titanium hydride, next zirconium hydride, all these are examples for this metal deficiency defect. Metal excess defects means due to presence of excess metal in the crystal, metal excess defects are formed. For example, excess of cations means example zinc, ZnO is example. So Zn, excess of zinc, due to presence of excess of zinc, excess of cations defects is formed. Excess of anions means so here sodium gas plus NaCl crystal. So this is I am explaining. So this is I am explaining here. Sodium vapor. If you take NaCl crystal, it is NaCl crystal. It is NaCl crystal. Metal excess of anions I am explaining here. Metal deficiency defect. Second one. See, it is Na plus Cl minus. Na plus Cl minus. Na plus Cl minus. Na plus, sorry, here Cl minus, here Na plus, here Cl minus, here Na plus, Na plus Cl minus, Na plus Cl minus, Cl minus, Na plus Cl minus, Na plus. I am taking NaCl crystal, NaCl crystal. Then it is mixed with sodium vapor. Then what happened means Cl minus crystal reacts with the sodium vapor and forms NaCl. Here vacant places are formed. These vacant places are occupied by the electrons, unpaired electrons. These vacant places are occupied by the unpaired electrons. These are called F centers. F centers. These are called F centers. Okay. So F centers means anionic places are occupied by the unpaired electrons are called F centers. F means for Benjenter. F equal to for Benjenter. Okay, these are called metal excess of anions defects. So NaCl I am taking, so reacting with the sodium vapor, then Cl minus and reacts with Na vapor, NaCl is formed, then extra sodium is present on the crystal, then it is nothing but a metal excess of cations, that is nothing but a excess defects of these F centers. F centers means so occupying means anions are occupying the unpaired electrons. Anions means anionic sites are occupied by the unpaired electrons is called F centers. So this is nothing but metal excess defects, excess of cations and excess of anions. Here due to presence of excess of cations this defect is formed. That is one more type, this is one more type. Next here impurity defects. Impurity defects means if you take sodium chloride which contains strontium chloride, due to presence of strontium chloride, so impurity defects are formed. Okay, this is nothing but imperfections or defects in solids. Got it? This is the way we may discuss imperfections and solids in defects in solids.